So, hello everybody. It is day 39 of studying math every day, and today I'm about to do 2 sessions. So, let's start studying, guys. Let's get into our first session. Kind of like I want to review, and I don't even know what to review. So, I'll see how it goes. Oh, I forgot to start the timer. So glad that I remember it. It's way too early.
Here we have a standard digits word problem. The problem reads, sum of the digits of a two-digit number is 7, and when...
Oh yeah. It's about to use substitution, right? Yeah. So yeah, I did use substitution. So here is it. So I plugged it in. It became 2x squared plus 10x was 12 squared. And I used this one with the y values. X plus y equals 10. 6 goes to the other side. It will be minus 4. So when x equals to 3, y equals to 4. On the other side, when y equals to, when x equals to, y equals to 6. Very reasonable. What about this second problem? X squared plus y squared. X squared plus y squared equals to 45. I'm gonna use substitution method. So 2x plus 18. Okay. And then I think when I was working on this problem, I literally forgot this part. I forgot this step that I have to. Nah, I did it right, but like I forgot that, you know, when we get off the square root, or maybe the square root of 9 is 3, or like it should be plus or minus. I forget the plus or minus. So that means x has two values, which is x positive 3 and negative 3. Like I literally forgot it when I was dealing with the problem. Okay. So okay, x squared plus y squared. Right, this is also the same. But what about when it is negative though? Did I check it that? Nah, even if it is negative, it doesn't make sense, because negative times negative, it will end up positive, right? So yeah, fine. On the other side, everything looks alright. So these are like, I think, linear system of non-linear equations. Yeah, these are systems of non-linear equations, and what makes them non-linear equation is if there is like 2x power, if there is power 2, so like if the power is more than 1, or if the exponent is like greater than 1, then that means it is a non-linear equation. So yeah, but like not the constants though, it is all about the variables only. Okay, so in this case I have used the multiplying y on one side. Nope. So I'm about to use substitution. So I did use a substitution. Okay. So 3x minus 5 equals to. Where did this 3 came from? I don't know. Okay. So basically I used this. So I plugged in y right here, as you can see. So and then boom. Okay, but like in this step I have to take out 10x outside, or maybe factor out 10x, because like it is the greatest common factor, and then divide both sides by 10x. But there was something that was so interesting when I was working on this problem. I remember, you know, this equation is something like this: 10x equals to 0 and x minus 3 equals to 0. It's just like kind of two equations that's, or like one equation at the same time. And yeah, I hope I will keep in mind that information, or maybe a piece, that piece of information. I hope I will keep it. X minus y equals to 5, 9, blah blah. Okay, what about this problem? 12x squared minus 12x minus y plus 19 is true. This is a little bit crazy, maybe. I don't know. Oh yeah. 2x squared minus 12x minus y plus 19 equals to 0. 2x plus... Okay, I'm gonna solve for y. That's what I did. I used a substitution. But like, could I use method, like elimination method? Could I? Because like... Nope, I couldn't. Because like this one got that power 2, like this one doesn't. And even this one is a lot, maybe more than that. It's just I have to multiply 2 at the top and 12 at the bottom. Maybe. So it could be longer. So substitution method was the, you know, easy choice and the easy approach maybe. But it was a lot easier. That's why I chose it. I got the x and I'm gonna substitute in the value of x, or maybe evaluating the value of x in every place that's x. So I use it the 1, the value of 1. It's got two values, 4 and 1. So I use it 1. So 1x equals to 1, y should be 9, or y is 9. And did I write the other one? 1x equals to 4. Yeah. Here is it. When x equals to 4, y should be 3. Yes. System is with 3 variables. Our systems with 3 variables. This is the best choice. I was looking for if there's any option, like if there is any highlight button, so I can highlight stuffs. Yeah. So system is with 3 variables. So we got x, y, z. So first of all, we need to cancel out one variable using like 2 of these 3 equations. That's what we need. So in this case, we eliminated what? I don't see. Okay, this I believe. This means 2y, if I'm not mistaken. Okay, so it became 2x and negative 2y, so that means they cancelled. Okay, fair enough. So it is 2x and it is what? 2x minus 2z equals 6, and then the total is 3x, 2z negative 2z positive z equals to negative z. This is a lot far away from the actual thing. Should have put it right there. Okay, and we got like wait up. So this is 2x, right? And this is the final. Where did I get this 3x from? Okay, now I don't know. 6, 4, 10. Okay, I'm gonna add all of them. That's what it is. So this was 2x. Wait. Did I mess something up? Or am I tripping? So this is like 2x minus 2y minus 2z equals to 2 equals to 2 times 2, which is 4. I don't even know where the 6 came from in general. It's kinda like little bit. Did I use the fairest one? Okay. X. Y, okay, I got Y also. So I didn't check the solution at all. Is that what it is? Okay, x, which is 1 plus 1 negative 2 is 4. This is 2 positive 2 equals to 4. 2 equals to, nope, it is then 4 equals to 4. This is kind of right, man. Like this part of the equation is concerning me. Like this part. So let me just put it in another way. So this is 2x, right? Like, what if I move all of it on this side and then say maybe x plus y minus z equals to 4, and then 2 times x minus y minus z equals to 4 times 2 also. So this is 2. And also this part is just positive 2y positive z equals to 1. So if I'm where this 6 came from, like it's not 6 at all, it is 2 times 2, which is 6. I don't know. So what up? So this, so I use it. Okay, so I didn't use this one. Maybe I use it like the first one and the second one first. So okay, so it is 2x minus z. So it is, they will cancel. So this is 2x, and then z and z, they will be my negative 2z positive 6. Okay, negative 2z positive 6. Okay, and then where this 3x came from? This 3x came from this, I believe. It came from 2x and then 3x, and then they will cancel, and then minus 2z positive z. Okay, it will be what? It will be negative z, and then 4. Okay, 4 and 5, and then that is how it came. So the first two equations that I have used was equation 1 and equation 2, not equation 2 and equation 3. So that is what I was missing, and that's what I was looking for. So all I wanted was to clarify that and to get an answer for my equation. Okay, but like this was tough in my opinion. It wasn't that easy. It wasn't that easy, and because like you can already see the answer, x equals to 3z positive 11 divided by 5. It's not that easy, man. Fractions are not easy at all. So that's the value of x. We're gonna get rid of the 5, and we get z negative 2. So we're gonna get the value of x using the value of z, and we got it. Yeah, not that bad, man. I nailed it. Yeah. second problem is this one: x minus y negative y blah blah blah. So I use it this and this to get rid of what? To get rid of z. So yeah, they are already. You can use the elimination method and you can eliminate the z. Yeah. So I wasn't recording. You guys couldn't see my screen the whole time. You guys couldn't see my screen the whole time. Oh, that's not good, man. That's not good. That's not good. So I didn't solve this problem at all. What? Okay, I didn't try this one at all. That's crazy. Oh. Okay, I'm about to try this one. I don't know if I have solved this problem or not, but like I'm about to try it. Like in my opinion, I think I did solve this problem. I did, for sure I did. So I'm gonna use these two equations, like equation 2 and equation 3, just to get rid of the y again. So this is what I'm about to do. I'm gonna do like, what is 2x blah blah, it is 3x negative 2y plus z equals to negative 11, and 2x positive y positive 3z equals to 9. I'm gonna get rid of y, so I have to multiply both sides of the equation by 2. You feel me? So this makes this two to, you know, to cancel out. So this is 4 for x plus 3, 4 plus 3 equals to 7. So it is 7x. So positive z, and also like, okay, so at the bottom 2 times 3z equals to plus 6z plus z plus 7z plus 7c. Okay, 2 times 9, which is 18. 18 minus 11. 18 minus 11, 7. Okay, I got this. And then what I need also is to get this and this and then add them together. So now I'm about to do this x plus 3z equals to 3 and 7x plus 7z equals to 7. So right here it will be Lx plus 10c equals to 10. Okay. But what I can do is this. So yeah, the greatest common factor is 2, I believe, if I'm not mistaken again. So I cannot use 4, I cannot use 3 too, I cannot use 5, so it is 2. So I'm gonna take 2 out, and I will have 4x right here plus 5z equals to 10, and then I'm gonna divide both sides by 2. So this is 4x plus 5z equals to 5. Okay. So now I want to get the x. So I'm gonna move this to the other side. The equation. So 4x equals to, it will be negative though, right? Negative z positive 5. Divided by 4 on both sides. So x equals to negative 5z positive 5 divided by 4. Don't know if this will be right, but yeah. So yeah, let me evaluate Augustine. Gonna use this first one. So x plus 3 z equals to 3. So x equals to what? X equals to okay. Okay. 2 alif z positive 2 alif z equals to 12. So negative 2 alif z, it will be 7 for sure. So it will be positive 7z. This one goes to the other side, equals to 7. So 7 divided by 7 equals to z equals to 1. Okay, and I'm gonna look for the x again. So z equals to 1. I'm gonna use the same. I'm gonna use this one. Maybe let me use this. Now I wanna get the x, so let me still use this one. Or maybe this one. I guess I can use this one and I can get the value of x. But somehow, like, I'm not literally sure, but like, yes, there is something that tells me I can use it. I can use that equation. That comes from these two equations. Plus 7z equals to 7. So 7x plus 7 1 equals to 7. So 7x goes to the other side, 0. So divided by 7 x equals to 0. Okay, now nope. So get rid of this. So let me use this one. X plus 2, no way. X plus 2z equals to 3. So x plus 2 1, which is 3. So x plus 2 equals to 3, and then x equals to 1, because like it will be in the negative, and then it will be just, or let's go, it is positive 3 negative 2, so it is positive 1. Okay, so I got the value of z and 1. So let me get the y2. Let me use this one. So it is 3x 2y positive z equals to negative 11. Okay, so 3, the value of x is 1, negative 2y plus z, value of z is 1 equals to negative 11. So 3 positive 2y positive 1 equals to negative 11. So 4 negative 2y equals to negative 11. So this one should go to the other side, and it will be something like 6, I believe. Nope, it's gonna be 7. It is scary if it is going to be 7. Nope, it will be okay. it is positive, so if it goes to the other side it will be negative, so that means it will be 15, I believe. Negative 15, that's weird, a little bit weird still, but yeah. Negative 2y equals to negative 11, negative 4, so negative, so negative 2y equals to negative 15. There is something telling me there is something that I messed it up. Like that ass. Okay. I don't think so. This right. There's something that's telling me it's not right. So I'm gonna double check it and I'm gonna use 2x. I'm gonna use this equation with the y again. Plus 3z equals to 9. So 2, 1, positive y, positive 3z, 1 equals to 9. So 3, 2 and 3, which is 5. So y plus 5 equals to 9. And then this one should go to the other side, should be like negative, so y equals to what it is, 4 or something. That's crazy. Okay, so let me check if this gives me 11 then. Yes, totally. This is totally wrong. So this is maybe -5. +1 equals to -11. So this is -4, I believe. Totally wrong. Yeah. Okay. This one got me, to be honest. Where did I get this one, by the way? It's just like, where? Systems with the equations. Where I got this one? Okay, it's this one. Z. Yeah, I got this one wrong. I think it is all coming from here, maybe. I cannot say it. So let me just take the 10 minutes of the break and I'm gonna give it a shot again. Give it a shot. My hair are in a bad condition, maybe. I don't know, man. They're getting longer though. So, see ya. I gotta go. Maybe to the toilet, okay? Whoosh. So let me give another shot to this problem. Right up. 3 times 4, which is 12. Z. This is 12. So 5. And Z and Z. Okay. Z 5 5 2 2 2 2. Okay. So let me go back to right here, man, one more time. Okay, dude, I think I'm missing something right here. So this one is missing already. Y. Have to get rid of this Y. So let me be careful of this bit. Gonna pull it up a little bit, and then yeah. So 3. So this is 4x negative 2y positive 6z equals to 18. So okay, so 3, 7, they will cancel basically. So this is 6, and that one is 7. So that means it is 7z, 18. So 18, let's be 11, 10. It's just 7, and this one is 0. Dude, this looks right. No matter what I do. Oh, I don't know what I'm doing. I literally don't know what I'm doing wrong, man. Crazy. Can I just like go back to one of my videos. I can see it. It was this day. Basically, minus 10. I go back to that question though. What should I do? I cancel. This one. Hello, hi everybody. It is minus 2 negative 2x, just like. So now I'm gonna
First equation by 2.
which is x equals to. Okay, where that negative 2 came from, that's what I need to know. What I have used. Hey, where this negative 2 came from, that's what I need. Like everything else is just like all right. Like I need this. What? Like 2 times 9 is 18. Okay, did I use something else? Okay. And then, dude, where did you get this? Okay. Yes, I was wrong on that. I was wrong on it. So, in this case, okay. I don't have to add. I have to isolate one of the variables. Like, I have to, yeah. That's what I miss. Dude, I did all of this and I'm about to clear all of them. Like, what? That's crazy. But yeah, this doesn't make sense. I'm about to do it because like okay. So to do this, I can just like tell me I can do this. I can x plus 3z equals to 3. 7x plus 7z equals to 7. So now I wanna get rid of the z. So multiply both 7 at the top and also 3 at the bottom. So it is 7x plus 21z. But this one should be negative. So negative 21 x and then negative 21 z. So 7, 21, and then 21. What the heck? Negative. It's negative by the way. It's like I'm gonna get rid of this z. 7z, negative blah blah blah. So this guy's they will cancel. And this is 14. Negative 14x equals to. It is 0, like that as. It is 2z by the way, not 3z. Okay. So multiply 7 on this side and 2 on this side. So it is 7x positive 14 z equals to 21. Then in the bottom, okay, negative 14x positive negative again 14 z equals to negative 14. So these guys, they will cancel. So this is negative 7 equals to positive 7. So this is negative 7, negative 7, is equals to negative 1. So this is my x. Okay, let me get a z. Okay, so x plus 2z equals to 3. So this is negative 1 plus 2z equals to 3. So 2z negative, it goes to the other side and it will be 4. So 2 and 2. So z equals to 2. Okay, good. We can use one of these three. So it is 3x negative 2y positive 2. So this is minus 1 minus 2y positive 2 or it is negative 3 negative 2y positive 2 plus 2, it's good I think. So it is negative 1 minus 2y okay, negative 1 okay, equals to negative 11 negative 2y equals to negative 10 divided by 2. So y equals to 5. So yeah, so finally x y z, so x equals to x equals to negative 1 y equals to yeah, well done. It made me a little bit like, you know, go crazy, but yeah, you know what I was missing wrong? The only thing that I was missing wrong was this. This is a system equation, okay? So to solve it, either you should use elimination method or substitution method, okay? So yeah, this is all I was missing wrong. All I was missing. So I fucked up this part. But yeah, not that bad, man. You know? I have to keep repeating again and again. And that's how you can learn. Okay, something else that I can give it a shot. To be honest, I don't know.
In today's tutorial, I'll show you how to host
I think like this video, the electricity just went out. I didn't end the session. All I need to do now is to take the bonus questions, dude. And it's not quick. If I do this tool, I'm about to call it today. Okay, I didn't save it. I'm dumbass. I didn't save it. Now maybe I should check my playlists.
Let's go over how to solve rational equations, how to approach them, what to look out for. So therefore, if you're taking a test tomorrow, or maybe you have a quiz, or you're just trying to refresh your understanding of solving rational equations, you have 3 examples that's going to help you do just that. So the first one I want to go over is going to be our easy one. All right. And usually if I was like in the classroom, this would always be like the first example that, you know, a lot of times I'd go in or start with my students. Now, I know some of you might look at this example and say, cross multiply, cross.
Yeah, the same. I'm not gonna cross multiply, but like what I would do is just that I would look for a common denominator, and the common denominator is just like 9x, so I'm gonna multiply 9x on both sides.
Cross multiply. And no, I don't want to do cross multiplication. You can. There's nothing wrong with doing cross multiplication. But what I want to do is show you a way to approach solving rational equations, because I cannot tell you how many times we do an example like this, I'll maybe show cross multiplication, or a student does this, and then they use cross multiplication when you're not supposed to. So what I'm going to focus on doing is identifying what we call the LCD, okay? I want to get rid of these fractions. I don't want to work with the fractions. I want to get rid of them. I do not like fractions. So what I want—
Dude, I do not like fractions too. I do not like fractions at all.
What you be able to see is like, all right, what is the smallest number term expression that my denominators are evenly going to divide into? So I have a 9 and an x. Now, the product, or the LCD in this case, is actually going to be pretty simple. It's simply just going to be a 9x. So what I'm going to do to get rid of my denominators is I'm going to multiply by a 9x times everything. Okay, a lot of times I'll put like brackets around it and say I'm going to multiply everything by 9x. But here's the cool thing: what happens when you multiply everything by your least common denominator? 9 evenly divides into 9 one time. Leave me here with an x times 2x. So I'm going to get a 2x squared. And that's the same thing if you were to do the cross product. X times 2x is 2x squared. Over here, my x's divide out, right? So I'm left with a 2 times 9, which is equal to a 8. Just like you were to go over here. Right?
That's how I would do it, man. Okay, so just divide both sides of the equation by 2, and it is x squared and 9. So, and then get rid of the square root. So yeah, it is just like x equals to 3.
Multiplication is faster, it's easier. But again, I'm showing you this process of the LCD because that's exactly what we're going to need to do for our next 2 examples. So now I just need to go ahead and use my inverse operations. I'm going to divide by 2 on both sides. I get an x squared is equal to 9. To undo the squaring, I'm going to take the square root. Just remember, when you introduce a square root, you have to include both the plus and the minus of your square root. So I have two solutions, x equals plus or minus 3. But just remember, when we're dealing with rational equations, we need to make sure that those solutions are going to be verified. They're not going to be extraneous, meaning these are solutions to this equation. We want to make sure they satisfy our original equation. If they don't, we call them extraneous. How do we know if they don't satisfy our original equation? To equations, we need to make sure that those solutions are going to be verified. They're not going to be extraneous, meaning these are solutions to this equation. We want to make sure they satisfy our original equation. If they don't, we call them extraneous. How do we know if they don't satisfy our original equation? If they make our denominator equal to 0. But if I plug a 3 or a -3 into this denominator, you can see I'm not going to get 0, right? So therefore, these two solutions are verified and we're good to go. Now let's go and take a look at another one where students will say, oh, let's go ahead and use cross multiplication, and they'll go ahead and get it all wrong, okay? So cross multiplication, ladies and gentlemen, only works when you have a proportion, a ratio equal to a ratio. So it's great for those kind, but
So this one also the same. I'm gonna look for what it's called. I'm gonna look for a common denominator for it, right? That's what I'm about to do. So yeah.
again, don't try to do it over here because it's not going to work. Well,
Oh, what will it be? It will be like x. Oh no, is it gonna be like this? Is it gonna be like this? X plus 6. The denominator gonna be something like this is the denominator. I'm not gonna say this is. It will be something like this, but it will be this. Okay, I
you'll
have
do
to be
something, but you're
confident,
not gonna
you
get
know.
the right answer. All right. So again, what I want you to focus on is identifying the LCD. Now, the LCD was rather simple, right? It was just 9 times x. And over here, a lot of times when we're thinking about, like, I need x plus 6 to divide into, like, what does that divide into? And the same thing, like x, what does x divide into? Well, if you think about it, ladies and gentlemen, the LCD is simply, in this case, just going to be the product of x times x plus 6. Because again, does x divide into that? Yes. Does x plus 6 divide into this expression? Yes. Since these are separated by multiplication, these two expressions are both evenly going to be divided by themselves. So what I'm going to do in this case is I'm going to multiply everything times x plus 6. And again, as long as you do that to every single expression that's separated by addition or this equal sign, you're not changing the solution. All right, so we're just going to multiply everything times x plus 6. And what that's going to do is we're going to get rid of the denominators, right? I want these denominators to divide into something, so I no longer have them. X plus 6 divides in with x plus 6, leaving me now
I guess
with just an x. Over here, my x's are going to divide into each other, leaving me with an x plus 1 times an x plus 6. And over here, my x plus 6's are going to divide into each other, leaving me just with a 13x. So let's go ahead and rewrite what we have because that looks a little messy. So I have a x times 1, which is just x. Over here, I'm going to have a x plus 1 times a x plus 6. And then over here, I just have a nice little 13x. All right. So it's a little bit more difficult, right? Now you can see I have a binomial times a binomial. Make sure we need to multiply that out, which you could use FOIL, you could think about distributive property, whatever may be the case. Let's see, that's going to be x plus, let's see, that's going to give me an x squared. Again, I'm going to do the math a little bit in the head. 1 times x is 1x. 6 times x is 6x. That's going to be a positive 7x. Plus 6. So I did that math in my head, but you can multiply it all out on a side sheet of paper if you want. And that's going to give me a 13x. All right, let's go ahead and simplify this before I
to the left side.
get to the next one. So x squared plus 8x
Plus 6.
plus 6 is equal to a 13x. Notice I have a quadratic. When we have a quadratic, ladies and gentlemen, we need to set it equal to 0.
Okay, yeah.
Once we set it equal to 0, then